LinceBI is a business intelligence solution based on open source oriented to analytics in big data. This platform has with a multitude of tools and technologies that allow to cover the wide spectrum of any BI project. The cornerstones on which LinceBI has been developed are agility. We will reduce the time spent on loading and analyzing data so that it can be dedicated to what is really important, decision-making. Capacity. LinceBI is a solution oriented to a flexible personalization and adapted to the needs required by each client. Usability. It offers clean, simple and user-friendly interface. We can easily adapt to it and we can use it from any type of device. Scalability. BI projects do not usually have a fixed size but tend to grow over time, and with it, the requirements of the machines dedicated to perform the BI flow. Therefore, LinceBI is designed to offer a range of possibilities from a server in a single node to a possible cluster of distributed nodes for large projects. Cluster of LinceBI is offered as a web service that gives us access to a BI desktop. From this BI desktop we can integrate and load our data from different sources, whether it is structured data, like databases, or unstructured data, Excel, CSV, and any type of plain text. We will be able to build analysis perspectives that represent our data in a pivot table format, and from which we will access the desired level of detail. We will have the possibility of designing interactive dashboards with related graphics and with the possibility of filtering. This tool would be geared towards management profiles. We can also model data reports quickly and easily for any business user. We will have the option to use customizable templates and filters to match the report to the data segment we want to display. Generation of balanced scorecards to weigh our indicators and evaluate the compliance of our strategic objectives. Bursting. Export to different formats with option to automatic planning and sending by mail. All this will be done from a modern interface with great usability. LinceBI also includes a series of additional functionalities that allow to expand the flexibility and power of the platform. Security. In LinceBI, the security of your data and its access is very important. For this reason, we can secure the accesses at data level or through Java database connectivity. Likewise, we can secure access to the content and the platform, either through the integrated user roles we offer, or by making use of solutions such as lightweight directory access protocol. Data integration. As already mentioned, we will have the possibility of connecting to multiple data sources through various connectors provided by the platform. We will also have the option of applying data quality techniques that will debug errors in our sources of origin, correcting errors prior to the exploitation of this data. Easy integration with web pages, either to embed external content within the platform or to embed views of the platform on our websites. Big data. We offer support for big data as well as data lakes through integration with Hadoop, Vertigo or Elasticsearch. With this, we may cover any online analytics processing or Internet of Things application. Real-time. Real-time analysis every few seconds, either for possible integration with various social networks, YouTube, Google, Twitter, Facebook, or for text analysis and logs. Machine learning based on classification, regression and clustering, with a wide range of options that can go from recommendation to predictive systems or possible simulated environments. For this methodology we can approach from different languages like Java, Scala or R among others. LinceBI has been developed with a modern interface using the Vue.js framework. This interface presents a series of perspectives from which we can access every aspect of the platform solution. Home. The main perspective and the entry point to the BI desktop. Here we will have a system of tabs that will allow us to organize the views in the platform according to the layout we need. By default, it has two fixed tabs: Global and Home. The first one will contain a list of files and views that will be shared for every user of the platform. In this way, as administrators, we could keep accessible in a fast way those general views of dashboards or reports with global scope. The second tab, Home, is an exclusive tab available to each user. Here he will be able to organize his views and work files, optimizing his work performance and allowing him to have an overview of the aspects of the company in which he works. Finally, every user will have the possibility to create their own custom tabs. This is done using the plus button located to the right of the tabs. We can create as many tabs as we need and we can define their name, color and associated icon. Also, you will be able to reorganize these customized tabs as you wish with a drag and drop system. As we have already mentioned, each tab will have a list of files or tool views. Each of these elements will have a list of buttons that will allow us to perform a list of actions. The first of them will allow us to reorganize the element inside the list of each tab. The next button will give access to the file's metadata so that you can modify several variables such as name, description and image. In the case of tool views, an additional button will be offered to enter the view's execution or editing mode. LinceBI will have a sidebar that will allow us to alternate between the different perspectives and will give us access to other special actions of the platform. The first button will allow us to access the perspective of Home that we have already mentioned. Tools. From the plus button, we can access the LinceBI tools that we have installed. We will talk about them later. Opened. In this perspective, all the views of the tools that we open will be placed, separated by tabs. We will see this perspective when we talk about the tool. File Explorer. In this perspective we will manage the file repository that we will have in the platform. It is composed of two main folders: Home and Public. In Home, subfolders will be self-created for each user once the authentication process is completed. Any file saved in these paths will only be accessible by default to the user himself and the platform administrator. In Public, it will be up to the users of the platform to organize a folder structure suitable for their needs. This path and its subfolders will be accessible by default to all users. Both Home and Public's default behavior can be overridden to allow access to only certain users or roles. Like any file manager, we can upload or download files, or rename folders and files. If you delete a file or folder, it will be moved to the special trash folder. From here we will decide if we delete the element definitively or restore it. Search. The search will lead us to a perspective where we can quickly locate the files according to their type, tool that opens it, location, data identifying text string, as we can see below. We will be able to make a search by type of tool by filtering through the following buttons of the search engine. Do a search by text string found in the title, description or tags. You can limit your search to only one or several of these search parameters. Narrow down the search using a date range associated with the creation date or modification date of the files. We will use the following inputs to define the start and end date in order to filter the search. Finally, we will be able to search according to the path in which the file is located. The search will be recursive and will search in all the subfolders contained in the chosen folder. In the elements shown in the search engine, we will have a series of configuration buttons. The first one will allow us to edit the metadata of the files as we saw in the home perspective. We'll be able to change the name, description, tags and image associated to the file. Two of the buttons, Globe and House respectively, will allow us to configure which elements will appear in the Global and Home tab of the home perspective. In this case, we have a olap view marked to appear on the user's Home tab. To configure the elements that will appear in the customized tabs, we will use the tags associated to the files. When the name of the tag coincides with the name of the Home Perspective tab, any file that has this tag associated with it will appear in the list of that tab. Likewise, for all those files in which we have editing permissions, the search engine will offer us a button that will allow us to open the view in the tool. We also have access to two additional search engine-related options that allow us to list favorite and recent files. Recent files. Files that have recently been opened from the user's session. Favorite files. Files marked with the star button in the file list. Once the favorite files are marked, we can access the special view of the search engine for favorite files. The same applies to the special view for recent files. Before we can work with the tools available in LinceBI, it is necessary to prepare our data sources so that they can be used from the platform. Our platform supports a wide variety of business sectors, from marketing and finance to public administration, industry and tourism. In the example of a company with a commercial orientation, we can have business intelligence systems that will allow us to control commercial objectives, will give us advanced reporting options, and will have powerful tools such as forecasting. In tourism, we can elaborate market segments by identifying trends and behavior patterns. All this together with dashboards that will agglomerate all the information we want to show. The first step will be to prepare a data warehouse or a data mart, depending on the scope we want to cover with a BI project. For global company data, we will use a data warehouse. For a subset of data associated to a specific business area, we will use a data mart. Performing this previous process of structuring and data cleaning will facilitate all subsequent phases of the project. To carry out this phase, we will previously make a process of analysis of the data and the sources from which it comes. Afterwards, we will use ETL tools that will extract, transform and load the data into our warehouse. We can use open source tools such as PDI, Pentaho Data Integration, or Talent Open Studio. Both tools have a series of connectors that will allow us to load data from many different sources, transform and clean it before loading it into the data store that acts as our data mart or data warehouse. In the following example, we will use the PDI components to load data from a table of an origin, perform an operation to generate a calculated column, and finally we will output the data into a table in our data warehouse. Talon displays a PDI-like interface and makes use of a similar component system. We can see an example similar to the previous one where a table is loaded from an origin, mapped using the tmap component to structure the data, and finally a output in the chosen target table. After preparing our data source for the platform, we will need to define the connection to that source or sources from the option, Manage Data Sources, so that the platform tools can access the data. We will have to fill in the connection data, and, as you can see, we will have a great variety of connectors in order to connect to the data source of your choice. In order for the tools to correctly interpret the data and its relationships, a business logic layer will be used to establish the relationships and properties of each data. This is where the advantage of having structured the information in a data mart previously is present, because the generation of these layers will be greatly facilitated. There are two types of logical business layers: Mondrian schemes, XML files, and report metadata, XMI file. Regarding the first type, Mondrian is the rollup engine used by LinceBI to structure information in a multidimensional way in cubes. Therefore, it will be in charge of structuring the information in dimensions hierarchized by levels, together with some measures to be able to exploit the information with the MDX language, multidimensional expressions. It is centered on online analytics processing tools such as StPivot and olap. The second type, report metadata, will establish the relationships between the data as well as its format, exposing only one layer of business that is easy to use. This metadata is optimized for mapping large amounts of data and is intended for use in conjunction with the StReport tool for reporting. Both types of files can also be generated with open source tools, such as Schema Workbench for Mondrian schemas and Metadata Editor for report metadata. The Schema Workbench interface will allow us to generate the Mondrian schemes. The schemes are formed by a root element, the scheme itself, and within this scheme we will find one or more cubes. Each cube in turn is made up of a series of dimensions that will allow us to filter and select the information. It also contains the measures with the data we want to quantify and aggregate. Both the cubes and the dimensions have an associated table from which they will extract the data. The table associated to the cube will allow us to extract the information of the measures of that cube. At dimension level we will find the information hierarchized in levels. The levels will allow us to access to a different detail level, allowing us to group or select the information in a more specific or general way. On the other hand, the interface of the metadata editor will give us the ability to generate the necessary metadata to create reports. We will define the connection to our warehouse and load the tables that will make up our metadata models. Once the tables are loaded, we will establish the relationships between them through the fields that relate them. The best way to structure the relationship between the tables is with a star model. The star model is structured with a central table that contains the data to be quantified, facts table, and the tables that make up the dimensions, which will allow the information to be filtered and selected, and are directly related to this facts table. Once we have generated the relationships between these tables, we will generate the business view. The business view will allow us to create some categories where we will group the columns of the loaded tables for the model. We will be able to define a literal name associated with the business process for these columns, as well as the format and possible aggregation, in the case of the measure columns. Once the Mondrian scheme and the relevant report metadata have been generated, we can upload them to the platform as follows. From the context menu of Manage Data Sources, we will select Import Analysis. From here we can upload the generated Mondrian schemas. We will choose the Mondrian file as well as the data source that will feed the cubes inside the schema. To import report metadata, select the Import Metadata option. we will choose the generated metadata file, as well as a text string that will be the domain name. The domain will allow to identify the models associated to the uploaded metadata file. Once we have uploaded our schemas as well as our metadata, we will be able to take advantage of the full power of the ST tools. First, we will talk about the olap and StPivot tools. These online analytical processing tools allow us to work with the Mondrian engine through schemes that we've loaded onto the platform. StOlap will provide a view from which the schemes loaded into the platform and the codes contained in those schemes can be seen. After selecting a code to work with, we will access the work interface. We will have a pivot table of analysis in which we can add a series of columns and rows, as well as some data filters. We can add measures to the columns using a drag and drop system, as well as some specific dimensions to the rows to cross the information. We can also select a dimension to act as a filter for the pivot table. In this exemplary case, we want to show the information of the quantity of products sold separated by countries, and only from the year 2005. Once the data to be shown is selected, we will switch to the display mode. Here we can see the result in the form of a pivot table as we have specified in the editing mode. This tool has a number of additional features beyond the pivot table. Formula generation. A series of measures or members calculated on the fly that add additional information to that contained in the Mondrian scheme. A list of logical, mathematical and aggregation functions can be used for this purpose. Summarize. Option to calculate a summary total of any of the measures shown in the pivot table. It will be shown in the pivot table as the last row. Analysis wizard. To generate in a fast and guided way a multidimensional expression query that crosses the data we need. We will define which data will appear in rows and columns, and the possible sort. What if? To generate conditional scenarios and to be able to define states of the measures according to their value by means of a system of colors and icons. Charts. There is an option to show a graph associated to the current value of the pivot table. It offers a wide range of graphics with which to visualize the analyzed information. Table. Various options on the pivot table. Swap axes, don't show empty cells, empty set, etc. Export. Export in various formats such as PDF, Excel, CSV. History. History of the multidimensional expression queries applied during the working session in the tool to be able to visualize a previous state of the analyzed data. Sending by mail. It offers the possibility of sending by mail a view of the pivot table that we have generated. Working with the tool, it is possible to generate analysis views like the following one. Here you can see the use of many of the features explained about the tool. Like StOlap, StPivot is an online analytical processing tool that will make use of the Mondrian schemes that we have in the platform. The StPivot work interface has many similarities to StOlap, but will have more advanced features. The olap browser will allow us to see the cube layout and will allow us to modify the information shown in the pivot table. In this case, we are going to filter the information so that only the 2005 information is shown. From the dimension editor, we will be able to generate sets associated to each dimension to facilitate a quick selection or create groupings beyond those offered by default by the Mondrian scheme. As in StOlap, through a drag-and-drop system, we can modify the information shown in the pivot table. Generation of formulas and calculated members. StPivot has tools to generate members and formulas of various types. What if? There is an option of conditional scenario to define states of the measures according to their value by means of a system of colors. Analysis wizard. To generate a quick and guided MDX query that crosses the data we need. Table. Various options on the pivot table. Change the behavior of the drill. Member, position or replace. Swap axes, do not show empty cells, etc. Charts and maps. There is an option to show charts associated with the analyzed information. It offers the possibility of creating snapshots to generate static charts that will allow us to show several charts at the same time. The map option should be used with geographical dimensions. It will allow us to see the disposition of that geographic dimension and the cross with the selected measure. Multiple regression and forecast. Advanced tools oriented to make predictive analysis. Export. Export in various formats such as PDF, Excel or CSV. Sending by mail. We offer the possibility to send by mail a view of the pivot table we have generated. In the LinceBI platform, there is documentation and audiovisual examples of this tool to know in depth all its characteristics and functionalities. After seeing the analysis tools, we'll move on to StReport. StReport is the reporting tool within LinceBI's ecosystem. It will make use of the metadata uploaded to the platform to allow us to generate reports quickly and easily. We will select one of the models contained in the report metadata to be loaded into the tool. Once loaded, we'll see the categories contained in the model and the fields that make them up. Each of these fields will have a descriptive text associated with it, as well as a possible format, default aggregation and other available aggregations. The report divides the information into columns, groups and filters. This will allow us to generate reports as we will show now. We will generate a report with 2 columns grouped by the territory field. We will also filter the report data by a date. Once we execute, the report will be generated automatically. As, by default, a summation aggregation has been done with respect to the total field, we can modify its configuration so that it applies another aggregation that it has available. In case you apply several filters, there is a pop-up window that will show you all the applied filters in a compact way. Also, to extend the report generation capabilities, we have the option to create calculated members. These calculated members can be created manually or with the help of a function wizard that will allow us to choose between different function categories. In the reports, we will have the option of parameterization. By default, in the edition mode we will define the composition of the report, while in the execution mode, we will not be able to modify this composition. On the other hand, we will be able to modify the value of the filters through parameters. In this example, we will be able to change the date filter to generate a parameter. So in the execution mode we will be able to change the date for the report to generate the data dynamically. This will give us a lot of flexibility and will reduce the number of views needed to reflect all the data in the reports. We can change the layout of the report and its style. Whether it's changing the name of the title or footer, even font formatting, colors, etc. As an added value, we will have the possibility to add simple graphics to our report. We will be able to add bar charts, line charts or pie charts. For example, the following configuration could be done. Show the information of the total value by territory, using the country field as a series of the chart. To know in depth all the functionalities of the tool, LinceBI platform has the documentation and video tutorials that cover every aspect of this tool. Finally, we will talk about the dashboard tools. StDashboard, StAgile and StCard. Each one is oriented to different aspects of dashboard generation. StDashboard will make use of Mondrian schemes to perform olap analysis using charts arranged in a dashboard. Once the desired schema and cube are selected, we will select the dashboard template. After loading the template model, we will see the elements where the charts will be embedded. In the pop-up window, a variety of charts will be offered to choose from. We will select an analysis perspective or dimension, and the indicator or measure to be displayed. With this simple action, we will directly visualize the data in our chart in a quick and easy way. After generating our charts, we must take into account that, by using the Mondrian scheme model as a data source, we can make cross-filters between the charts and navigate through the different levels of the dimension used. This will offer us different perspectives of analysis and will keep the chart synchronized. We will have advanced chart configuration, measures, color selection, type of representation, format, as well as additional options. We can also define the title and perform a chart anchorage. The anchoring prevents the chart from being filtered when browsing or filtering. External content embedding. Option to embed content from an external website or a view from one of the ST tools. The next dashboard tool we will cover is StAgile. StAgile will allow us to load data into CSV to create dashboards in a simple and powerful way. We will be able to load the CSVs both from the internal repository of the LinceBI platform and from our computer. Once the CSV is loaded, the work interface will be loaded, which is composed of 3 perspectives: options, dashboard and data table. In the data table you will see the data loaded from the CSV, and from here you can filter the columns that interest you. In options you can configure the charts that will be shown in the dashboard. By default, the tool generates a basic configuration, depending on whether the column is numerical or string. However, we can change this configuration by the one we define. In the example below, we will configure a chart that reflects the national consumption information by car model. We will also define that the information is shown in top order. And finally, we will change the color range of our chart for a different one. The resulting chart will be as follows. We will have a series of varied charts to cover all the needs of dashboards. From bar and line charts to advanced charts such as bubble, heat map or box split. There is also the possibility of embedding external content or HTML code to create custom content. The number option will generate a card type chart for a value to which an aggregation function will be applied. The charts can be resized to take up more or less space. And we can change the title of our dashboard. Finally, we will talk about the SD card tool. SD card is focused on generating comprehensive scorecards, allowing the control of the strategic objectives of each area of the company, according to some KPIs. The following example of a scorecard is composed of 3 areas of the company, and each area is composed of its own strategic objectives. In turn, these strategic objectives are composed of a series of indicators. The operation of the tool is very simple. We will load some data for each indicator and each month, which will be the target value that is expected to be obtained and the real value attained. In this way we will be able to calculate the percentage of compliance with the indicators each month. With these compliance percentages, we will be able to calculate the compliance with the strategic objectives and the areas of the company. From the configuration, we will be able to define the weight that each indicator has within each strategic objective, and the weight that each strategic objective has within each area. There are 2 types of indicators, quantitative and qualitative. The qualitative type maps the values of the domain that composes it, according to the possible states available. The quantitative type allows the definition of the aggregation associated with the values that compose it, minimum and maximum limits to discard values outside the trend, if the goal is going to be to minimize or maximize the value attained, and the numerical limits that define the change between the different states. From data we can manually modify the data of our scorecard. We could modify the target value of an indicator so that it uses a reference value from a previous year. We can also define an operation performed with respect to that reference operator to attain the new target value. Finally, it is important to emphasize that we can modify our scorecard to make use of the platform's user and role system. In this way we could limit that each user only sees the part of the scorecard related to his area within the company. For these 3 dashboard tools, the LinceBI platform also has documentation and video tutorials that cover all the characteristics of these tools. Thanks to all these tools, we will have the ability to generate views for our BI project that will allow us to analyze and improve our decision-making. In the following, we show several examples made up with the tools of the LinceBI platform. If you have any questions about the tools and how they work, we remind you that we have a support website where we can answer them. We have already seen several of the possible exploitation capabilities of the LinceBI platform at tool level. Now we will see the options of management available to the platform. To do this, we must access the administration perspective from which we can control various aspects of our BI platform. From the management of roles and users that we have previously discussed when we talked about the file browser, Mondrian and metadata. Even the management of the internal cache. From the administration option, we will have the following options. Users and roles. We will have the ability to create, modify and delete users, as well as associate the roles that include the permissions of those who they will dispose. Once the user has been created, he or she must be assigned a role, so that he or she has the appropriate access permissions. In the role management, the same procedure is applied as in the user section. We will be able to have total control over the roles and over the operation permissions that each one will have. The operation permissions are the following. Administer security. Permission reserved to the administrator user that will allow them to have access to this configuration. Schedule content. Permission to schedule the automatic generation of files. This feature is useful for the dynamic generation of reports at StReport level. Read content. Permission needed to list and view files and folders in the platform's repository. Publish content. Permission that allows us to generate and save views of the ST tools that the platform has. Create content. Permission to open and edit new views of the platform tools. Execute. Permission to be able to open already generated views of the tools in visualization mode. This permission does not grant the capacity to edit or create new views. Manage data sources. Permission to access the menu to create the connections to the databases and upload our Mondrian schemes and report metadata to be able to work with the ST tools. Finally, we have the system functions. Here we will define the permissions of the internal roles of the platform in order to allow an authentication anonymous, for example. It is important to emphasize that in case of deriving the authentication system to an authentication such as Central Authentication Service or Lightweight Directory Access Protocol, these tabs will remain disabled when managing such systems. These capabilities. If you want to use any of these systems, you can contact us to help you perform the necessary configuration for the integration. We will be able to use this system of users and roles to configure the access permissions on the files and folders of the platform's repository. This way, from the File Explorer, we will have a Properties option on both folders and files. This pop-up window will allow us to change the visibility of this element by checking the Hidden option. A hidden element will not be shown in the File Explorer unless the user has activated the option of the contextual menu on the top right, Show Hidden Files. From the Sharing tab, we can change the permissions of this element. By default, the file system has a permission inheritance system, so all files and folders are inherit the permissions of their parent folder. To change this behavior, we must uncheck the Inherit Folder Permissions option. This way we can add or remove users or roles associated with that element. For each user and role defined, we'll be able to change the permissions in a more detailed way. By default, they will have the read permission, but we can add write, delete, or full control over the element. Returning to the administration perspective, we will have the option of Email Server. Here we will be able to configure our mail server. This will help us to make available sending from ST tools such as StReport or StPivot. From the configuration option, we can control the deletion of files generated automatically by the platform to avoid their accumulation. We will be able to define a period of validity, and any element that does not comply with it will be automatically deleted. We can also execute this deletion in a manual way. Manage data sources. We have already seen this system during the presentation of the ST tools. It will allow us to define the connections to our data sources, upload the Mondrian schemes for the online analytical processing tools, and our metadata for the reporting tools. Schedule. Here we will be able to configure and list the schedules established on the platform. The schedules will execute an action periodically, according to the configuration that we have established. We will see which file or process acts as the source, as well as the possible generation of an output file if it is the case. Likewise, we will see the last execution date and the next one, as well as the scheduling status. We will be able to stop the execution of the whole system in a manual way, for example, during a maintenance of the platform. We will have filtering options to be able to make a concrete search in case we have several schedules. And we can edit the scheduling to change their execution period. A practical use case would be the automatic export of tools such as StReport. For example, from the File Explorer we have the calendar option for certain views of generated tools. From here we can schedule the execution so that a report in the desired format is generated periodically. We can define the name of the schedule, a possible timestamp associated to that name, the report generation path, and the option to overwrite if the file already exists. In the next step we will define the execution recurrence of our scheduling. We'll have several options for the recurrence. Next, we will have the StReport parameters with which the scheduling will be executed. In this case we want to generate a PDF file in Spanish. In case you have an email configuration active, we will get an additional step where we can define the automatic sending of the automatically generated file to a mailing list. Cache cleaning. Finally, we will have full control over the cache. LinceBI tries to cache all the requests made from the to minimize the impact on data sources in the platform itself. The available cache is separated into several categories. System configuration. Cache related to the internal configuration of the platform. Report metadata. Refreshes the information associated with the metadata uploaded and used by StReport. Global variables. Variables associated to each user of the platform. An example would be the options in the upper context menu or the language. Mondrian schemes. Refreshes the information associated to the Mondrian schemes used by olap, for example. CDA cache. Cache associated to the internal tool used by the StDashboards to define data origins. Each user will have their own profile. Here you can define the personal data of your user and upload a profile picture. To finish the management aspects, we cannot forget to mention that LinceBI is a multi-language platform, so we will be able to switch between several languages easily. By default, the language of the web browser used is chosen if it is available, but we can change it from this option. That will automatically change the language of all the perspectives of the platform. In order to be able to manage and exploit any BI project correctly, it is important to be able to keep a proper control of the processes that are carried out, as well as the use of the tools available to exploit the information. With this in mind, StAdmin was created. StAdmin is a set of systems and processes that will allow us to control every aspect of our BI project, from data loading to its exploitation, or give us new features that facilitate our work. The first tool is ST Monitoring. As its name indicates, it allows us to monitor the performance and use of LinceBI. We will be able to analyze the data associated to the sessions and access to server content. The tool has a main view as well as a series of views associated to the different ST tools to be able to visualize the information in several ways. The main view consists of two tabs. The first one will allow us to study all the accesses made to the server tools, either to generate new views or to open already saved views. A separation is made between access to analysis views, reports, dashboards or others through graphics. The second tab, Users, will allow us to see the data associated to the user session, the maximum, minimum and average time of the sessions carried out in the platform, as well as the data of number of sessions and access of content of each user. Finally, we will have a date selector to be able to filter the information as required. The next tool we will talk about is StAudit. StAudit will allow us to monitor the state of the ETL processes deployed in the production systems. This monitoring can be done at the process or activity level. It will be possible to see information associated with processing times and activity, start and end time, process status or number of errors. As in ST monitoring, a main view of the tool is offered, and a series of views generated with the ST tools to complement the information. The main view will provide graphs associated with processing and activity times, as well as the number of errors. These graphics can be filtered according to various aspects of the information that represent. The information can also be filtered by range of dates, by the client associated with the ETL process, or by the project to which the ETL process belongs. Apart from being able to see the processes already completed, you will be able to see the processes that are in execution. After seeing the monitoring tools, we will move on to see the tools that offer additional functions. StValidations is a LinceBI plugin that allows us to check the differences at data level between the source systems, transactional, and the data warehouse after the execution of the ETL process. For this purpose, systems have been implemented for both Pentaho Data Integration and Talend Open Studio, which will allow us to compare the differences between the result of the query in the source system and the result in the target system, data warehouse. This way, we can check the consistency of the data in the data warehouse. This process makes use of a table containing the pairs of queries to be compared between the source and target systems. StValidations will run each pair of queries automatically, comparing the data from both systems to later save the result in another table that can be analyzed. We will be able to use the information obtained through Mondrian schemes, report metadata and dashboards such as Power BI and CDE. The last StAdmin tool we will see is StAdmin. StAdmin is an XMLA connector that provides us with connectivity to olap clients and XMLA data sources. In this way, it will allow us to interact with XMLA compliant data such as Mondrian and SAP. An obvious advantage of this tool is being able to bring the powerful technology of pivot tables into Excel. Keep in mind that multidimensional expression queries can return a large amount of information, and the system has been designed with this premise in mind. The speed and memory consumption has been optimized, allowing this tool to offer an agile work without repercussions for the source data sources or Excel. Apart from the features explained throughout the video, it is worth mentioning that the LinceBI platform has the following capabilities: big data and machine learning. Both big data, large-scale data processing, and machine learning are very important in the business intelligence developed nowadays, and LinceBI allows a coupling with the technologies dedicated to exploiting both disciplines. You can make use of various tools such as Apache Hadoop, which is a distributed analytical server and considered the big data environment par excellence. It will have HDFS, a distributed storage, and Yarn, a runtime resource manager. It will also have a series of technologies that will extend the range of big data processing tasks. Qilin. It is a distributed analysis engine that offers an SQL and multidimensional analysis interface that will allow us to exploit the information by visualizing it with different tools. In this example, we have analytical tools like StPivot or more visual tools like Superset or Power BI. In StPivot, we will have a Mondrian scheme that structures the information in dimensions and metrics. While in other tools such as Power BI, we will have a more visual perspective through the use of graphics. Apache Spark, a cluster computing framework that improves the performance of big data applications through intensive use of RAM. In the following example, we have a system for predicting sales based on several parameters. Hadoop and Spark are used to visualize the information with Zebulon. We have other examples that make use of Apache Kafka or Spark streaming. In the following example, you can get the Wikipedia updates in real time, thanks to Apache Kafka. In this other example, we can list the new articles that are created in Wikipedia by using Spark streaming. These integrations require a high degree of knowledge and customization for each solution to be implemented. In the case of wanting to have big data and machine learning features in LinceBI, you can contact us without obligation in order to evaluate your needs and assess the necessary implementation.